Nice to have you, my wonderful scholars. Today we'll continue with solving jump pass question. Question number 2. The question goes this way. The height at which the atmosphere ceases to exist is about 80 kilometers. If the atmospheric pressure on the ground level is 760 millimeter mercury, the pressure at a height of 20 kilometers above the ground level is. Okay, let's try explaining the question, because understanding the question is a part to the answer. Okay, the question targets to check the student's level of mastery of atmospheric pressure. Okay, the first thing you need to know is this. The atmospheric pressure is the pressure of air around us. And this atmospheric pressure is greatest towards the ground. And its least at the Earth's outermost layer, the exosphere. Where the air ceases to exist is the exosphere, where there is no air anymore. At that point, the atmospheric pressure becomes zero. So what do we mean by atmospheric pressure? The air is being pulled down by gravity, and air acts most on us, the humans or the organisms or the objects on the ground, because all air are being pushed down towards the earth. So towards the ground level have the highest atmospheric pressure, which is 760 millimeter mercury. The weight of the air is on our head. This simply implies that when a body begins to leave the earth's level or the earth's surface, the atmospheric pressure on that body begins to do what? Reduce. Take for instance, someone standing on the ground and someone standing at mountain top do not have the same atmospheric pressure. The one on the ground has a greater atmospheric pressure, while the other person at the mountain has lower atmospheric pressure. Why? Because the person at the mountain has gone through air. The person must have passed some amount of air. So every air below the person is not acting on the person. Therefore, the air pressure has been lowered. So what's the point in summary? The point is this. On the ground surface, the atmospheric pressure is maximum, and it's a constant, because the quantity of air in the earth's surface is intact. Therefore, the greatest atmospheric pressure, which is towards the earth or on the ground, is 760 millimeter mercury. While the one far away, where the air ceases to exist or ends, which is the exosphere, the last layer of the atmosphere, the atmospheric pressure there will be what? Zero. Because there is no air there. Therefore, the atmospheric pressure becomes what? Zero. Okay, let's see what the question is targeting. Here, the question is saying that the height at which the atmosphere ceases to exist is 80 kilometers. That means the distance from the ground surface to the exosphere is 80 kilometers. Let's solve on the board. Solution. So we'll put the first line to indicate height. So from the earth's surface to where the air ceases to exist, 80 kilometers. Then distance or the height of the earth's surface itself is 0 kilometer. So why is it 0? Because the measurement begins from the ground. So 0 kilometer. Then where the earth's atmosphere ends, 80 kilometers. So we'll continue. Then we'll have another line so that we can do a comparison of the atmospheric pressure and the gap or the height. Okay, remember what we said. The height, when it comes to height, on the ground is 0 kilometer. But the atmospheric pressure on the ground is maximum. It's maximum. The person on the ground and the passenger in the airplane and the plane itself don't have the same atmospheric pressure. There is less air pressure or atmospheric pressure on the plane. That's why the plane goes far, so as to lower the air pressure on it. But humans have more air pressure on them, and which also affects our height. So towards the ground, we have the greatest atmospheric pressure, which is 760 millimeter mercury. While at the peak, at that 80 kilometer, at the exosphere, we have 0 atmospheric pressure. That is 0 millimeter mercury. The millimeter mercury is unit of pressure, atmospheric pressure. Okay, the instrument for measuring atmospheric pressure is barometer. Barometer takes advantage of heights to measure pressure. Okay, see why it is millimeter mercury. It's a very simple idea. Okay, in a barometer, we have something like a U-tube. Then you have to seal one end. Seal it. I just want to prove to you why atmospheric pressure is measured in millimeter mercury. So you know that the unit of pressure is somehow or indirectly unit of height here. That's why we say millimeter. Then let's see why we add mercury to it. Pour mercury inside. When you pour mercury inside this U-tube, then seal one end and open one end. Air enters from the other end. And it's been observed that the air will push the mercury, that the mercury rises up to a certain height, and that height is 760 millimeter mercury. Recall, here must be sealed so that air can only push from one end. When air pushes from one end, it pushes the mercury upwards from the other sealed end, making height of 760 millimeters. That's why we say that, and it's constant. Anywhere you do it in the air surface is the same. So the atmospheric pressure in the air surface is 760 millimeter mercury. Okay, so let's continue. So we've seen the comparison. At height of 0 kilometer, we have maximum air pressure. At height of 80 kilometers, we have minimum air pressure. So the question asks, the pressure at a height of 20 kilometers above the ground level X. Then height of 20 kilometers, what will be the pressure? Then observe the units, kilometer. Then you place maths. Go to the part, go to the fundamental interval that has kilometer. Then ask yourself a question. 20, is it going to be in between 0 and 80 or otherwise? After counting 0, we'll count 20, then count other numbers before we get to what? 80. Let me presume that the middle is 40. Therefore, half of that 40 is what? 20 kilometers. Then common sense will tell you that the pressure will also be somewhere here. After drawing the middle, then half again. That's X. So that is the atmospheric pressure we are looking for. X stands for the atmospheric pressure we are looking for. We are done with the comparison. Let's now do the arithmetics. Okay, here we'll follow a simple arithmetics. Anytime we make this type of comparison, you can also see this type of comparison in conversion of different scales of temperature. Here we have different units that indicate one thing. Kilometer and millimeter, they can be used to measure atmospheric pressure. You can attach mercury to it to prove to us that it's mercury that is being pushed inside the U-tube to show the level of atmospheric pressure available in a planet. So what point am I trying to make here? There is a common formula after making this type of comparison, and the formula says, now we'll take it this way, shorter height divided by total height. Okay, let me indicate. Shorter height divided by total height equal to shorter height from the other end divided by each total height. Okay, let's go. Okay, let's solve here. So 20 minus 0 is the shorter height. Divided by 80 minus 0 is the total height. Is equal to X minus 760 is the shorter height. Then the total height will be having 0 minus 760. That's the common formula. Shorter height divided by total height equals shorter height divided by total height. Then carry on with the arithmetics. 20 minus 0, 20, 80 minus 0, 80 equals X minus 760 retains itself. 0 minus 760 becomes minus 760. Okay. Then cross and multiply. Okay, 80 times X will be giving us 80X. Recall, there is plus here. Plus times minus, minus. 80 times 760. We got 60,800. Okay. We're done with that part. Recall that is equal to, is cross and multiply, which is equal to, maintain your equal to 20 times minus 760. I'll be having minus 15,200. Okay, then let's come over here. So we can place those values better. We now have 80x minus 60,800 equals minus 15,200. Okay, collection of like terms. Here we have 80x. So I'll be moving minus the other way to make it plus. Then minus coming here becomes what? Plus. When minus crosses over equality sign, it becomes plus. Then this minus retains itself because it didn't cross over the equality sign. Minus. So 80x is equal to, then 60,800 minus 15,200. We'll be having We'll be having 45,600. Okay? We can round off here. Okay. Okay. Here we have x unknown. We'll be dividing both sides by the coefficient of the unknown, which is x. Then finally, x becomes 570. Then recall in physics, quantities must go with their unit, their appropriate units. We're talking of atmospheric pressure here. Therefore, the unit should be millimeter mercury. Okay, let me tell you something. There is something great about physics. After solving, if you understand the theory, you will know whether you are correct or wrong. Okay, let me tell you what I mean by this. If the atmospheric pressure at the exosphere or the point where the air ceases to exist is 0, and the one on the ground surface is maximum 760 millimeter mercury, then at heights 20 kilometers above the ground, common sense will tell me that the atmospheric pressure will do what? Will be lower than 760 and greater than 0. Recall the maximum is towards the ground. So when you shift away from the ground, you should have something less than 760. If you have anything greater than 760, then impossible. So I'm expecting something lower than 760 because the maximum is towards the ground, 760 millimeter mercury. So moving away from the ground, I'm lowering the atmospheric pressure. Then let's see if my answer is lower than 760. 570 millimeter mercury. So I'm correct. 570 millimeter mercury is the answer. Option B is correct. Thank you. Please stay tuned on this platform as we do more justice to jam past questions.